In this video, we are going to see about 8087 processor pin diagram and interfacing of main processor 8086 with the coprocessor 8087. This is the pin diagram of 8087. The pin diagram is similar to 8086 maximum mode except the pin 23. Pin number 23 in 8086 is test pin, but here it is busy pin. But remaining pins functions are similar to 8086 maximum mode. Coming to interface of 8086 and 8087. As a coprocessor, 8087 is connected to 8086. 8086 operates in maximum mode, thus the pin MN/MX bar is grounded. Then 8254 provides the common clock, reset and ready signals. 8282 are used to latch the address. 8286 are used to data transceivers. And 8288 generates the necessary control signal using the status pins S2, S1 and S0. 8259 is a PIC, which is programmable interrupt controller or priority interrupt controller, which is used to accept the interrupts from 8087 and send it to the main processor. This interface is also called as coprocessor configuration. And here 8086 is the main processor and 8087 is the coprocessor. To understand this interfacing, we will consider a program. For that, I am going to a flow diagram of interfacing interaction between 8086 and 8087. 8086, we all know that it has an instruction queue of 6 bytes. So it's the same way, coprocessor also maintain the instruction queue of 6 bytes. So whatever instructions get loaded in the instruction queue, the same will be copied in the coprocessor. The reason is that it wants to monitor its own instruction by using the prefix instruction called escape. This escape prefix is identified by 8086 as no operation instruction. That means it is directly understood that coprocessor instruction. So once the main processor sees this escape prefix instruction, it sends a wake up call to coprocessor. Then coprocessor accepts this instruction, and after accepting it, it deactivates the host test pin, because the test pin is an active low pin. To activate it, we have to give logic 0. That is why it is specified as deactivate the host test pin and execute the specified operation. The specified operation program can be an opcode, sometimes opcode with operand. That means operand means the data will be stored in a memory. At that time, if it is a single data, then 8086 helps coprocessor to fetch a data, because the coprocessor doesn't calculate physical address. Physical address is 20 bits. So the data will be sent from main processor to coprocessor, then coprocessor executes this operation. In some other cases, it may require more data to be fetched from the memory. At that time, coprocessor takes the control of system buses, which we can see clearly in the previous slide. At that time, coprocessor sends a request signal to the pin RQ/GT to take the control of system buses, that is data bus and address bus, which is always sent through the pin RQ/GT0. It is sent out from 8087 and it is received by RQ/GT1 in the main processor. So once the main processor accepts this request, it grants the control of the system buses and it is given back through the pin 33 to the coprocessor. So now the coprocessor takes the control of the system buses, it starts executing its program, and afterwards it stores the result. Then again it sends a request signal to the main processor to take back the control of system buses. After that, it activates the test pin to indicate that it has completed its operation Now no need for waiting of main processor. Next the main processor will go to the next instruction to continue its execution. This is how the interaction takes place between 8086 and 8087. So this completes the interaction between 8086 and 8087. In the next video we are going to see about data types of 8087. Thank you.